This is the second video for lesson 3.4 in Honors Geometry. We're going to take a look together at the proofs in this video. So we're going to start with this question number 5. As soon as you read any proof, most important thing is to go ahead and to mark your diagram. So I see that AM, segment AM is congruent to segment BM, and I'm going to mark that. I'm trying to prove angle AMO is congruent to angle BMO, and I want to really make sure I notice these angle symbols here. I'm not trying to prove triangles. I'm going to go past that and prove that the angles are congruent. As we go through these proofs together, please feel free to stop and pause the video, try something on your own, and then come back to the video and check your thinking there. So when I look at this, in the very beginning, I see that I don't even have triangles to prove congruent. So what I'm going to do is use the auxiliary lines that you talked about in the first video. So I am going to go ahead and I'm going to draw in segment OA and segment OB. And I'm going to write this as draw segment OA and draw segment OB. The reason we want you to use for auxiliary lines in your proofs is 2 points determine a segment. Okay. Once I know that those 2 points are in there, now I'm going to say that those 2 segments are congruent to each other, with the reason all radii of a circle are congruent. Make sure you mark that into your picture as well. Pause the video here, try and finish this proof, and then come back to it. Welcome back. I hope you really paused the video. I'm going to say segment OM is congruent to segment OM by the reflexive property. And then I can say that triangle AOM is congruent to triangle. Now I'm looking for the image of A, and the image of A, this would be a reflection, it looks like to me, would be point B. The image of O would be O, this would be M, and those triangles were congruent by side, side, side. Lastly, I can say angle AMO congruent to angle BMO by CPCTC. Okay, 1 proof down, 2 to go. So I'm going to go ahead and I'm going to look here at my second proof. PS is an altitude. When I look at this altitude, I know that altitudes are going to make right angles. So I'm going to write that for myself as scratch work. And then I see that PS bisects angle RPQ, and bisecting is going to tell me that I'm going to get some congruent angles. So I'm going to set this up with my statements and reasons. I think I'd like to start with that second given. PS is bisecting angle RPQ. So I have to find this angle up here, RPQ, and I know that it's being split into 2 congruent angles. Angle RPS congruent to angle QPS. If a segment bisects an angle, it forms 2 congruent angles. Now I'm going back to my first given, and I'm looking for the right angles. So PS is an altitude. That's going to mean it's going to form right angles down here at RQ. So I'm going to say angle RSP and angle QSP are right angles. Here's where I need to think back to my notes from before. I need to think about which if-then statement or which version of the definition of an altitude do I need. I know that I have an altitude and then I'm trying to conclude that I have the right angles. So I'm going to start with an altitude of a triangle. Forms right angles with the side to which it is drawn. Try finishing the proof from here. See if you can get the whole proof finished. Pause the video and see. I hope that after pausing the video, you were able to get this far. You need to say that the two right angles are congruent to each other. Then you need PS congruent to itself by the reflexive property, so that you can get the two triangles RPS and QPS congruent by angle side angle. Now I'm trying to get segment PS as a median of triangle PQR. That means I need a segment that goes from the vertex of a triangle and divides the opposite side into two congruent segments. So the two congruent segments I need to state are going to be segment RS congruent to segment SQ. That is CPCTC. And then I'm able to say that PS is a median of triangle PQR. And I need that reason. So again, I'm thinking back to the first video. I had two different reasons that went with median. Either a median of a triangle divides the side to which it is drawn into two congruent segments, or a segment from a vertex, if a segment from a vertex of a triangle divides the opposite side into two congruent segments, then it is a median. I know the two congruent segments in step 7. I need to get the median. So I need that second version. I need this one. If a segment from a vertex of a triangle divides the opposite side into two congruent segments, then it is a median. Okay, we have one more proof. Make sure that you mark your diagram. And I'd like you to pause the video, try that proof, and then come back to that. If you'd like to talk to your partner about the proof when you pause the video, that's all right as well. Welcome back. I hope that you tried this proof and paused your video. So we are looking here at proving two triangles congruent and using those triangles to prove our angles. Did you remember to put this step in here of drawing segment IE? Make sure that you don't just draw it in your picture, but you also include that as a step in your proof. Then we needed to get 3 pairs of congruent sides. Also remembering to use this reason of all radii of a circle are congruent. Be careful that you include the whole reason. And then 2 triangles that are congruent, matching up the order of the letters. So the image of point L is point N. Remember that they go from the 2 same sides. And then angle L congruent to angle N by CPCTC. Thanks for watching. We'd like you to go ahead and get started on your homework. You should still have about 15 to 20 minutes left in class.